Right, so here's one of my sets, which is the Lowe TX40 with a knob missing. Distributed by Lowe Electronics, or custom made for Lowe Electronics, who were at Matlock in Derbyshire, and with the Trio, before Kenwood was Kenwood, it had to trade under Trio in this country because of Kenwood, as in Kenwood Chef. So, like Radio Shack couldn't trade as Radio Shack because of the initials RS and our existing business of RS components. The Lowe TX40 is a World Sound PT40. It's slightly different, and it's the best version of the World Sound PT40. There are at least 3 versions of the World Sound PT40, and one that has PA is better than the one that doesn't have PA, in my opinion. But this has an extra circuit, and we have the full service information. We have the circuit that came in instructions. We also have the trader service sheet. I scanned this for A3, and I don't currently have an A3 printer online, so we do have the full information. Whereas with the other version, you've got to kind of read between the lines. This is one we bought some years ago. It's come with half a power lead. It's got a socket it shouldn't have on the back. And I think we're going to open it up first. These side screws are the kind of side screws that came with the SW711 speakers, so they don't belong to that radio, even if they're the right thread. These are one of the few radios that, when new, we had to turn every one of them down because they were coming out doing 5 watts. Unfortunately, these are self-tapper screws. Are they supposed to be? I can't even remember if they're supposed to be or not. I'll tell you what, let's take one of the others out. Yeah, they're all self-tapper, so that looks like they are. So first thing we're going to do is unsolder the speaker. It's a bit of a short lead. It's a lot of a short lead. Let's get the clipboard. If I recall, these used the SINAD standard wiring. Let's see what it says here. Yes, it does. It's 1. Don't think it needs a receive wire. Probably because it has a relay. It's quite some time since I've seen one. So we've got the Grandstand Hawk. There's another PT40, and it's probably the next best. I think it's the 16th today. It really doesn't matter. I do actually have an empty gift box. I don't know whether this one came in it. Right, well, that's a good start. We've opened it up. Basically, the transmitter's around here. What on earth has somebody done? It's a screened lead. Going to round capacitor 123. which may just be an empty hole, or it could be a missing part. It is a missing part. It's 0.0022. Let's look at the key here. Capacitor 123 is actually the end part. Variable resistor 4 is what? Is it the I think it could be the delta tune. It's deviation. Variable resistor 4 is deviation. So we need to reinstate that and get rid of that. So they've fed in an external input, probably from their special effects unit from their disco. So we'll come back to that. But they must have changed it tonally by removing that capacitor. I was beginning to wonder if it was going to read the received delta tune. Which is the first thing you've got to set. It's all J hooked in. It's, you know, done like somebody knows what they're doing. Thing on the floor, and in a few years' time, somebody might sweep things up. Right, that's got rid of the junk, but we need to add the capacitor, but we don't need to do that at this stage. It would be prudent to look underneath. In case there's some circuit board that's come from a Space Invaders game. No, that's what you'd expect. Is that capacitor supposed to be there? .022. Didn't we say the missing capacitor is .022? Yeah, we did. So chances are that's our missing capacitor. Right, we'll get it connected up. So we'll worry about that when we do the deviation. So I'll connect to our test gear through extension speaker, connect to our PA speaker mounted on the wall, connect this up to power, and we will switch on 13.8 volts. now is a standard microphone. Oh, that's noisy. Oh my goodness, let's cut the power and we'll see if we can deal with that straight away. But chances are I won't have got an applicator here. There's a planet where applicators go. That one's empty. I better not chuck that on the floor. See whether there's any improvement. There's half the stuff. There's far too much stuff on here. And if I start tidying up, it's probably where this job will end. Right. I'll have to deal with that properly. Obviously, spring in the right direction didn't work. Right, switch PA on, it is on.
Testing 1 2, testing 1 2.
Switch to CB on, it's on channel 20, that's handy. That to full, delta tune to the off position. We're on high power. Let's switch picture in picture on. Once again, I'll mention when I switch that on. And it also has appeared in the monitor. The radio's doing 3 watts. Better than yesterday's set that did 330 milliwatts. Channel 1, 3 watts. Channel 40, 2.7 watts. Back to channel 20. And low power selected. 210 milliwatts. And back to full power, 1.15. Deviation for what it's worth. Bearing in mind that needs looking at. Wow, it's 3.2. Nothing like playing your records loudly. I bet that's what they were doing. We don't have. Do we have a VCA method? We're not going to do it unless we need to. And let's see where we are on frequency. Now, the test gear's only been on for 15 minutes. So we'll take this with a pinch of salt. It's 27,79097. 27,79097. It's not really out, but it will obviously we'll be pulling that up. When we key up, the meter goes across to what? It's labelled 0 to 1. You know, it's slightly low. I can't write it down because it doesn't have any normal calibration. Let's go over back to the main meter. I'll just quickly put 27,79097 in the signal generator. So we're testing the receive at the frequency on which the radio is working at the moment, so it's a totally fair way of doing it. So I'm going to put S9 on at the moment, try and cope with this iffy volume control, and we're getting, it's a very generous meter, and at the moment S9 is 13, is 38 microvolts. Let's see where we are with the sensitivity, because it sounds quite sensitive. Put the SINAD meter up. Let's see what we've got. There's 12 dB. 0.57. It's about where you'd expect it. 10 dB. 0.49. And will it do 20? It will. And between scales, we'll give it the benefit of the doubt, say 1 microvolt. Squelch. Like it to be 100 microvolts, but there's no hard and fast rule on that. So it's not opening at 100, opens at 165. And the threshold is 1.85. Be nice if that was better. Right, so basically we've got a working set. Just needs that demodification thing. I will see if we've got another set, just to see if there's any shenanigans underneath that I don't know about. He says sensitivity is typically 0.2 microvolts for 12 dB SINAD. So there you go. One of the first things you've got to do is set the delta tune, if I remember. So it goes through the test equipment you're likely to need. 2 amp power supply, 20,000 ohms per volt or electronic multimeter, frequency counter up to 30 megs, RF power meter reading up to 50 megs, FM signal generator going 27 megs with deviation up to 1.5 up to 2.5 kilohertz deviation, and RF multivolt meter to read 10 to 300 millivolts. That's why we have that Russian one behind us. And then here's the nitty gritty: oscilloscope to read audio, spectrum analyzer if available, and SINAD meter if available. So it's a strange way of doing it. I think we're going to go through. They're going to start with the receiver, which I think is totally against my training. But because you've got to set the delta tune first, that's what they're doing. So we could go to like 0.4 and then switch the transmitter. But on the other hand, we could go along with this. Select channel 1. Looks like we're going to do the VCO. Connect RF voltmeter to test point 1 on the printed circuit board. Adjust coil L4 for maximum. So the first thing they want you to do is to get your RF voltmeter out. Test point 1. Come on, give us a clue. And L4 is where? So there's L4. We've got jumper 1, we've got jumper 2, but no, I can't see any test points shown. So now we're going to have to bury our head in. This is going to be a long video. Test point 1. Test point 4 is in fact pin 19 of the phase lock loop chip. Is that what we were looking for, or were we looking for test point 1? Have I lost the plot already? No, we're looking for test point 1. Test point 2. Test point 1. So it's one leg of L4 or one end of capacitor 68. I think it's going to be easy to find one end of capacitor 68. 4 picofarads. Capacitor 69, capacitor 68. So our test point is going to be there. It's been nice if they'd have printed test point 1. And then we've got to get this enormous Russian probe into that tiny bit of the circuit. So we're adjusting L4 for peak, not for a given voltage. L4 is this one. And it was absolutely spot on. Doesn't mean to set you do is though. And that kind of sets the frequency, part 1. Wonder what we're doing now. It's even more off frequency. So you're looking for, it's doing maximum activity, isn't it? That's what that's about. So connecting a frequency counter now to test point 1, adjust CT2 to 10.24046. and this also will be fun. And then adjust CT2. And CT2 is there. We can't do the usual thing where you put it into transmit and set the frequency because of this pesky delta tune circuit. You've got to go through all this rigmarole instead. .2408. We've got 10.2408. We want 10.24046. So it's slightly high. Yeah, of course it'd be better if we had some hook-on probes. So I haven't got enough digits, so we're going to... I could use one of the other counters with more digits, but I've got it at 10.2405, which is about where they want it to be. Because we're going to be double checking all this with other equipment. Out of interest, I wonder what it's on now. It's miles out. Connect a multimeter to test point 2. Right gambit of test gear. And of course we don't know where test point 2 is, do we? We know where 4 is. 2 is there. So it's one end of capacitor 26 or one end of resistor 8. It's the join between resistor 8 and resistor 3. Well, there's resistor 3 and there's resistor 8. Resistor 3, resistor 8. Chances are it's going to be that point between. We could prove it by turning the radio off, going into buzzer mode and going between so it is, you can either use the loop there, or you can drop your remote on the floor, or you can go to the far end there. I can't remember whether these are a floating chassis or not. Switch it back on. Let's find out. Chassis is negative. So back to the instructions. Far end of resistor 8, and we want 2 volts. Adjusting CT2 to read 2.5 volts. No, CT1. So we've done CT2, there's CT1. 2.5 volts. It's about as close as we're going to get that. Oh, set your meter to 2.5 volts, set the actual thing for 2 volts. That was confusing. tell they were using an AVO 8 with its 2.5 volt range. Select channel 20. And connect your RF meter to test point 3. Adjust L2 for maximum. L2 is that one. So we'll need to junction of, it says, to go back to this, junction of C63 and L2. C63, 69, 68, 67, 63 is there, and L2. There's C63. So get your big Russian device back. Oh dear, won't be able to do these at the usual tariff. Not much movement there. And there we have peak. That did need a little bit of adjustment. With channel 20 still selected, they're actually going to have you tune it up using the S meter, which of course is all well and good back in 1981 when SINAD meters weren't really around. So we won't do that because it isn't as accurate. Right, so we will switch over to picture in picture onto the SINAD meter because that's where we've got to. I'm going to... there's a stage here which they haven't thought about. I've got to check what frequency this is on. It's difficult to tell, isn't it, because of the delta tune. 2779. It's instead of it being, well, it's far more off frequency than it was when we started using their technique. Right. So let's go through receive. But we're using the SINAD meter. Find the camera remote. Yep, picture in picture is on. So it's L14, 15, 16. 14, 15, 16, 17, 18, 19 and 20 if we know where 19 is. 14, 15, 16, 17, 18, 19 and 20. Nineteen's there, shown as 11 in the service manual by mistake. That looks like the detector, and you wouldn't do it in this normal way. Let's just look at that, if it is the detector. Let's go to the oscilloscope. Actually, that's going to be the detector, isn't it? Oh, I've got the squelch on. There we go. I didn't give him a chance there. That's connect oscilloscope across the loudspeaker and adjust 21 for maximum recovered audio. So that was the next stage. Increase the signal generator and adjust variable resistor 3 for S9. So we'll adjust it to where it should be, and we'll do VR3. I think some of these are sideways on, aren't they? There's 4, 10, 3. There's S9. And then what we're going to do, squelch. Yep, VR2 is the squelch. VR3, VR2's there at the back. That's a funny position for squelch. Right, squelch to full. See whether we can back it off. Oh, you know what? That isn't squelch, is it? Oh, here we go. It says it is. Preset VR2. Let's adjust the squelch on the front panel to see where we are. It is preset squelch. I've got it at maximum sensitivity. So it's 165 microvolts, which is where it was. Oh well. So it looks like that's kind of received done. Let's look at transmit. So adjusting coils L5, 6, 11 and 12. 5, 6, 11 and 12. They missed 8 out. That must be, that sets the power, does it? 5, 6, 11 and 12. 5, 6, 11 and 12 power set with 8. So we're going to transmit. To about 3.2 watts. Still off frequency. I don't know how they're going to trim that. Or perhaps their method was near enough. We're at 3.2 watts. About what you get out of a new set. Not going to quite get there. It's about 3.8 watts, but of course I've been running it now for a couple of minutes, so it's going to be a bit warm. But we'll write that down. Go to the other channels. Channel 40, 3.7 watts. Channel 1, 3.8. Back to 20. 1.34. Okay. Adjust preset variable resistor 1 to line up with the 9 on the receive meter. That's how they do it, is it? Variable resistor 1 is there. So that's where they say it should be, on that mark. High-low power. Making sure the delta tune's off. Here we go. Making sure the delta tune is off. Just preset at VR9 to set the frequency on transmit. And I knew it was some strange method. Let's see if we can get it to go. VR9. It's that one. Just put that up on the test equipment. So on 2779125. He's not going to go with the method set. So what we're going to have to do to compensate is, we were doing CT2, weren't we, with the frequency counter. So we're not going to touch CT1. least I don't think we are. No, because that was part of the VCO. We're going to adjust CT2. I'm going to keep that at full. Like that. So we've got now that at full. Yep. And hopefully the delta tune will be correct. Shouldn't affect transmit, just in case it's been messed with. That's fine. And then with variable resistor 4 we're going to do deviation. Now I'll do it roughly, but we've got to faff about with that capacitor. Wallow. We'll check it on the other test set as well. Variable resistor 10 is the low power. So there's variable resistor 10. So let's go to low power, switch that back onto the main meter, switch to low power on the radio, and let's get ourselves 400 milliwatts. Just like that. Out of interest, let's see what we're now on. Yes, 3.8. So here goes. What's the SINAD reading? Is it better? Is it worse? Let's look what the delta tune does to it. Yeah, well, it certainly shifts it about. Oh, 0.64 is worse. I'll just go through the front end again off camera, and at the same time when we come back I'll do the deviation. Right, I've been through the receiver again. What we're going to do, because I'm not happy that this is on frequency on receive, got the other signal generator out to use it as a marker oscillator. So we've got on the main test set with the correct frequency on the signal generator of 27.79125. Well, I'll just get that exactly on. So if I press transmit on the radio, we have 27.79126. So I'll just can back that off probably slightly. And now, can you hear that musical note? I'll turn the volume up. So we've got this on 10.695. So now we're going to null that. So we know that this is the frequency we've already set. We know this is the transmit frequency. So we're going to null the receive frequency. So I've got my delta tune to 0. If I switch my delta tune on, it never quite gets to the right frequency. So here goes. Now when I switch the delta tune on, works as it should. So it's now you know what, folks, there's no core in this one. This could be our issue. So I'm going to dig out another. This is a PT40, also with a missing volume knob. It's just a very generic PT40, and it doesn't have PA. And if I can manage to open it up, you see it's got a different layout. Totally different. So it's quite difficult to find your way around. Do all these cores have cores in them? And the answer is yes, they do. Well, we can bring a third into the equation because we've got a very, very poor condition Grandstand Hawk. And we've got PA on this. Now then, is it the same as the TX40? So I've never compared them side by side. It looks like it is. Well, I didn't know that. And do we have a core? Well, this is bizarre, because why would that be filled with wax if it's not got a core in it? Because it's exactly the same. Well, that's useful to know. So at least we can look at the underside, because we've now... I'll do that later when we've sorted this out, because we can now look at the issue with that capacitor that's been messed with. So I'll sort it out between this. So there is a capacitor underneath, but it's a different one. So that's going to help immensely. But I'm still not satisfied that we've got this on frequency. So we'll go back to looking at our transmit. We've now got 27.79146, it's very slightly high, but we've got it as low as we can there. We've got the radio on frequency. As low as it'll go. And if you put the signal generator on, let's see where it really is. So it's actually very slightly low. We can correct that with the delta tune, but I want it to be null in its off position. It just isn't going to do it. I think that's the best compromise. Very, very slightly high transmit and very, very slightly low receive. But I'd like to see another one of these to see whether that's supposed to have a core in it. I just don't get why the wax is there, and yet our Grandstand Hawk is just the same. And let's see where we are for the SINAD meter. So for 12 dB, it's 0.62. For 10 dB, it's 0.51. For 20 dB, that can't be right, it's because it's worse. So let's go through the detector again. S9 on. Now how's that adjusted itself? Miles out. I'm just going to go through these. I'm going to have to go through the IFs again, having discovered that. I was going to say, well, of course it could be worse because we've done the detector. Right, we'll start again. So I've done the detector again. That's made a massive difference. 0.29. 0.25, and 0.61. Unbelievable. Better recheck squelch. Yes, about where it was. Let's get the threshold. See, that's still not good. It's actually worse at 2.5. Just make sure we are at minimum. It was number 4, wasn't it? Was it? about 1.6. So not the best squelch in the world on this particular set. Quite adequate, but it's not like 2.5, which is where we did have it. So, well, that's a minimum, which is not ideal. It's not the first set to be like that, though. 400 milliwatts, we can fill that in. So, we've got 2779 140 for TX and 2779 117 for RX. Now, it shouldn't make any difference, and nobody else goes to this kind of trouble. So we're going to see how that is on the air test. They're a weird set, and they're hated by nearly everybody. I get on with them normally, and there we have it. I just need to sort the deviation out and get these this capacitor back where it should be on the other side. It's not got that linked across. Let's see what part of the circuit we're talking about here. Round resistor 113, 109. $113. I think these is to increase mic gain or make the deviation ridiculous. Take that out as well. So we'll just put it to one side for now. So that's the diode gone. Probably play the music louder through that socket on the back. Right, let's have a look at the deviation now. Wow, it's over 3 on this test set. Right, we'll plug it into the other test set. Let's see what the other test set makes of it. Wow, it's 2.9-ish, so just get that dropped off. VR4 is there. Wow. I don't know why some people want to make the signal wider. Just go onto several channels at once. It only sounds louder to people with poor filtering. Right. So, final check. Testing 1 2, testing 1 2. Right. Loads of gain there. And all the screws I took out of the Hawk, no, I didn't take any out of the Hawk, all the ones I took out of the PT40 were M3. So I think we're going to make sure all these holes are threaded using the threading tool for M3. I don't like to see self-tappers, but I can't prove what should be in here. It's too long ago since I last saw one. Right. It's just a whisker away from 4 watts when you key up from cold. I'm going to put the bottom on so I can do the absolute final alignment. Right folks, that's all back together. There's one or two things I do need to come back to, and that's the case screws. Internal speakers working. And we'll borrow a knob from some piece of scrap. Viewer sent some knobs in, so we'll have a look through those. Let's put it onto the area instead of the test gear. Just very slightly high on frequency on transmit and very slightly low, all within what's permissible by a long way. Be fun without the knob. Tell you what, we'll do the knob now. I'll go and get the bag of knobs. Right, well, any old knob will do, so there we go. One on a Roger. See this channel selectors, which is dirty. They're self-wiping, so it will sort itself out. I've had it on the shelf a good 10 years. Right, there we go. The Lowe TX40 from 1981. What a swine to set up. Thanks for watching.